morning students. Today I am going to discuss how to convert and manipulate the data of different types. In today's presentation, you are going to learn how to perform the conversion between a string and a numeric data. And for that conversion to take place, it requires a set of classes. And this set of classes comes under a package which is called java.lang.star. Now let's start with the two most common classes that comes under the package java.lang.star. These two classes are integer class and float class. The integer class deals with the int data type and it provides methods to convert int type to another type. The commonly used methods of the integer class are parseInt and signum. Let's start with the parseInt method. Now just see the chart. The parseInt method is declared as static int parseInt. Then within bracket you have the type string and then the variable name str. This method returns the integer equivalent of the number contained in the string. That means if you declare a string which resembles a number, using the parseInt method, the equivalent number contained in the string will get returned. And remember that strings are always enclosed within inverted quotes. Now say for example, if the string is 123, which is enclosed within inverted quote, then the equivalent integer that will be returned by the parseInt method will be 123, but it will not be within inverted quote, as this becomes a number. And the Java code to perform that conversion will be int n followed by a semicolon in the first line. Here n is a variable of type integer. Then in the next line you have n equal to integer.parseInt, then within bracket there is the string 123 within inverted quotes. Here the method parseInt converts the string 123, which is inside inverted quotes, into an integer. And that's why in the output you can see the integer 123. Now let's come to the next method, that is signum. Just see the chart in this slide. It is declared as static int signum. Then within bracket you have the type as int and then the variable called num. Now if the variable num is negative, then signum will return -1. If the variable num is positive or -0, then signum will return 0. And if the variable num is positive, then signum will return 1. Say for example, if you assign the value 1, 2, 3 for num, then signum will return 1. The Java code for that will be int followed by a space, then the variable name n, and then a semicolon in the first line. Then in the next line you have n equal to mat.signum. Then within bracket put the value of num, which is 1, 2, 3. On writing this Java code, the signum method will return 1, as num having the value 1, 2, 3 is a positive number. Similarly, when the value of num is minus 1, 2, 3, then signum will return minus 1, as can be seen in the chart. And that's why in the chart, whenever you supply the positive value of num, that is 1, 2, 3, the output is 1. And when you supply the negative value for num, that is minus 1, 2, 3, the output is minus 1. Now see this chart again. When the value of num is 0, then signum will return 0. Now if you refer to this chart, you will see that when you supply the value of num as 0, the method signum returns the result as 0. That's why in the output you can see the result as 0. In the previous slide, I have discussed about the integer class. Integers can take positive or negative numbers such as minus 1, minus 10, 50, 70, 100, etc. But integers cannot take decimal values such as 5.3, 6.2, 7.21, etc. For working with decimal values, there is another class known as the float class. The float class provides methods for converting and manipulating the floating type values. And floating type values are the decimal values. The two commonly used methods of the float class are parse float and parse double. The difference between float and double type is that a float type can represent smaller or medium-sized decimal values, whereas the double type can represent larger decimal values. Let's start with the parse float method. Just see how it is declared in the chart. The parse float method returns the float equivalent of the number contained in the string. Say for example, if you have declared the string as 1, 2, 3, then using the parse float method, it will be converted into its float equivalent, which will be 123.0. Now, we have clearly seen that 123 has been converted into its decimal type, that is 123.0. This is because we have used this parse float. And in this way, the parse float method returns the float equivalent of the number. And the Java code to do that will be float n followed by a semicolon in the first line. Then in the next line, type n equal to float dot parse float. Then within bracket, put the string 1, 2, 3 within inverted code. The next method is parse double. See the chart for its declaration. This method returns the double equivalent of the number contained in the string. Say for example, if you have declared the string as 15100. Then using Parse Double, it will be converted into its double equivalent. As you already know that double represents larger decimal numbers, so this Parse Double method will convert the string into a double equivalent, which will be 15100.0, and the Java code to do that will be double D followed by a semicolon in the first line, considering D as the variable name. Then in the next line there is D equal to double dot parse double, then within bracket put the string 15100 within inverted quote. And on executing this Java code, the string 15100 will be converted into its double equivalent, that is 15100.0, and so it becomes a decimal number. So that's all for today. In the next presentation, I will show you some Java programs. Those programs will make use of the classes and controls that comes under the Java GUI components.